So to do questions 4, 5, and 6 ask me to sketch the graph of each inequality. So I need to be able to find the vertex of this. There are a couple of ways to be able to do that. I'm going to go ahead and do completing the square on this one. So since my a value is not 1, I have to take that a value out. So I've got negative 2 x squared minus 2x plus a blank, and then minus a blank. Half of negative 2 is 1. 1 squared is going to be 1. So I'm going to plus 1, and then I subtract negative 2 times 1. So I add 2. So in vertex form, this is going to be y is less than or equal to negative 2 x minus 1 squared plus 2. So now I can see where my vertex is. It's going to be at 1, 2. To find my next points, my a value, so I stretch down, that's the 1. For my 3, I'd go down 6. So it looks, there are some of my points. It's going to be a solid line because it's or equal to. And then it's less than, so I want to shade below. So I go to my vertex and I go below, and I don't cross those lines. Looking at 5, again, I need to get this into vertex form so that I can easily graph it. So I have x squared minus 6x plus the blank plus 5 minus a blank, half, that's negative 3. Negative 3 squared gives me 9 that I add, so I then subtract 9. This becomes my trinomial square. So I have y is greater than x minus 3 squared minus 4. So that puts my vertex point at 3, negative 4. And because my a value is just 1, I follow the normal 1, 3, 5 pattern. This is a dotted line because it is not or equal to. And again, it wants y values greater than, so I go to the vertex and I choose a point above it, and that is where I shade, not crossing out from the lines. 6 is already in vertex form for us, so I can easily just find the vertex. I go to negative 3, negative 2. That's my vertex point. And then my a value is 3, so instead of doing 1, 3, 5, I would do 3, 9, 15. So from here I go up 3. From there I go up 9, which would be off grid. Because this is not or equal to, it's going to be a dotted or dashed line. And then I want y values that are less than. So I go to my vertex, I choose a point that is below it, and I shade until I get to the line. I do not cross my line, so everything out there is what is shaded on this. Questions 7, 8, and 9 want us to graph the systems and solve the systems. The solutions are going to be where the two lines cross. So if looking at 7, I have negative 2x squared plus 3. This is the same thing as if it had been negative 2x plus 0 squared plus 3. So my vertex point is at 0, 3. My a value is negative 2, so I go down 2, and then I go down 6, so it has that look to it. The other equation that I have is y equals 1, and that's just a horizontal line going across when y is 1. So I want to know these intersection points right there. I'm going to write my answers as ordered pairs. This is a two-solution type situation. So I have two ordered pairs I need to write. One of them is at negative 1, 1. The other one is at 1, 1. With this one, my vertex is at 0, 4. And again, I open down, but it's just a 1, 3, 5. So I open downward like that. This one is just a linear function. It has a y-intercept of 2 and a slope of 1. So I go up 1, over 1 to get my next points. I can go in the opposite direction as well. So my line goes about like that. So again, I am looking for the intersection points right here and here. So this one is the point negative 2, 0, and this one is the point 1, 3. Again, it crosses at 2 points, so I have two solutions. I have to include both of them. For number 9, I need to get this into a form that I can easily graph from, so I'm going to put it into vertex form. So I pull that negative 2 out of the first and second terms. Half of 2 is 1, 1 squared gives me 1 there. To figure out what goes on the outside, negative 2 times 1 is negative 2, so it's minus negative 2 or plus 2. So this is y equals negative 2 x plus 1 squared plus 1. That tells me my vertex point is at 1, 1. To figure out my next points, I follow this a of -2, which makes that 1, 3, 5 become -2, -6, and then I'm off, so I don't care anymore. So it looks like that. And I have the other equation is y equals 4. So that is that line right there. These two lines don't cross, so this is no solution. (10 through 15) are all dealing with solving by factoring. First thing with solving by factoring is I need to set it equal to 0. So here, I need to subtract 24 from both sides. So I get x squared plus 2x minus 24 equals 0. So I am looking, when I make my x factor, I'm looking for two numbers that multiply to give me -24. They multiply to my c value, but add to give me 2. They add to my b value. So something that multiplies to -24 is going to be 6 and -4, which does add to give me 2. These two numbers here tell me what my factors are going to be. So it's going to be x plus 6 from that one, and then because this is a -4, it's going to be x minus 4, and it equals 0. The only way for two numbers to multiply together and equal 0 is if one of them equals 0. So I set each of these equal to 0. X plus 6 equals 0, or this one, x minus 4 equals 0. I solve for x, I subtract 6 from both sides, and I get x equals 6. Here I add 4 to both sides, and I get x equals 4. And those are my answers. Looking at this one, again, I need to subtract 24 so I can set this equal to 0. So I have x squared minus 5x minus 24 equals 0. So I make my x factor. I'm looking for numbers that multiply to give me -24, but when I add them together, they give me -5. So this time, I want to use the numbers -8 and 3. -8 times 3 gives me -24. -8 plus 3 gives me -5. So this then factors as x minus 8 times x plus 3, and it still equals 0. I set each of those equal to 0. X minus 8 equals 0, or x plus 3 equals 0. I add 8. X equals 8. Here I subtract 3. X equals -3. Looking at number 12. It's already set equal to 0, So I'm looking for two numbers that multiply to give me 64, but when they add them, they give me 16. Again, multiply to my C value, add to my B value. Well, that's going to be 8 and 8. So this one, I have x plus 8 times x plus 8 equals 0. So I set each of those equal to 0. So I have x plus 8 equals 0. Now, you notice these are the exact same thing, so I only have one solution, and it is x equals -8. Even though it happens twice, I only need to write it once because there's only that one solution. With 13, 14, and 15, things are slightly different because I have an a value that is not 1. So with 13, when I do my x factoring, when a is not 1, what goes up top is the a value multiplied by the c value. And what goes on bottom is still my b value. So here, on top, I need 3 times 4. So I need two numbers that multiply to give me 12, and what goes on bottom, but I need them to add to give me -8. Well, that is going to be -6 and -2. But because I have an a value here, I also must remember that whatever I get there, I must divide both of those by that a value. So I need to divide both -6 and -2 by 3. If it can simplify it. -6 divided by 3 is -2. That is going to be one of my factors, x minus 2. If it cannot simplify, what's on bottom goes in front of x, what's on top trails behind. So my factors here are x minus 2 and 3x minus 2, which equals 0. And I set both of those equal to 0, so I have x minus 2 equals 0, and I have 3x minus 2 equals 0. So here I add 2 to both sides, and I get x equals 2. Here I add 2 to both sides, and I get 3x equals 2. I then divide both sides by 3, and I get x equals 2/3. So those are my two solutions. Looking at question 14, if you are able to, you want to try and take out a greatest common factor. So here I have 6x squared plus 66x plus 60. All three of those are divisible by 6. So I can divide both sides of this equation by 6. Here, when I divide each of those by 6, it gives me x squared plus 11x plus 10 equals 0 divided by 6 is still just 0. Now I'm dealing with a much easier situation to handle. So I make my x, and I want it to multiply to 10, but add to 11. That's going to be 10 and 1. So my factors are x plus 10 and x plus 1. I set each of those equal to 0, So I have x plus 10 equals 0, and here I have x plus 1 equals 0. I subtract 10 from both sides on this one, so I get x equals negative 10. On this one, I subtract 1 from both sides, so I get x equals negative 1. Here, again, I need to get this equal to 0. So I have 15x squared minus 27x minus 6 equals 0. All three of those numbers are divisible by 3. So I'm going to divide this all by 3 on both sides. When I divide this by 3, that gives me 5x squared minus 9x minus 2 equals 0. I make my x factor, and I need it to multiply to 5 times negative 2, which is negative 10. And I need it to add to my b value, negative 9. That's going to be negative 10 and positive 1. Because I have an a value that is not 1, I divide both sides by that a value. So I divide both sides by 5. If it comes out nicely, I simplify it. So that's going to be negative 2. This one cannot reduce, that stays as 1/5. So I have x minus 2 here, and here I have 5x plus 1 equals 0. I set each of those equal to 0. X minus 2 equals 0, and here 5x plus 1 equals 0. Solve each of those for x. X equals 2. Solving this one for x, I get 5x equals negative 1. I then divide both sides by 5, so I get x equals negative 1/5. Those are my two solutions. Again, solutions in this form are wanting to know where it crosses the x-axis. When I'm looking at the systems from 7 and 8, 7, 8, and 9, the solutions are different. It's wanting to know where the two lines cross. The last ones we have in 16, 17, and 18, I wanted me to write the equation in standard form with the given characteristics. So for this, it's giving me the focus and the directrix. So my focus is the point negative 3, 2. My directrix is y equals negative 2. So that is down here. Directly between my focus and directrix will lie my vertex. So my vertex is going to be right here between the two of them. So my vertex point is at negative 3, 0. I need to start by putting this equation in focus form. my p-value going from my vertex to the focus, I go up 2. So my p-value is positive 2. I can use that information now to write this equation in focus form to start with. So I have x plus 3 squared equals 8 y minus 0. Because it's minus 0, I don't need to have it there, so I just have 8y. To get this to standard form, I need to first move it over to vertex form. So I divide both sides by 8. So I have y equals 1/8 x plus 3 squared. Standard form of an equation, if we remember, is y equals a x squared plus bx plus c. This, I need to do order of operations to get it into standard form. Order of operations says do exponents first. So I need to FOIL this. When I FOIL that, you do x plus 3 times x plus 3. You get x squared plus 6x plus 9. But all of that, I have that 1/8 in front of it. So I have y equals 1/8 x squared plus 6x plus 9, which is saying I need to divide each of these parts by 8. So standard form will be y equals 1/8 x squared plus 6 divided by 8. That lets me reduce to 3/4x plus 9 divided by 8 does not simplify, so 9/8. There it is in standard form. Looking at 17, I have a vertex of 4, 3, and my directrix is y equals 7. That is the top of our grid here. So I already know my vertex. That will give me my h and k. So my focus form is going to be x minus 4 squared equals, I need to know 4p. Well, p is distance going from directrix to vertex. So I move down 4, so my p-value is -4. Therefore, 4p is going to be -16. And then I have y minus 3. To get this into vertex form, I divide both sides by -16. So I have y minus 3 equals -1/16 x minus 4 squared. And then I would add 3. So y equals negative 1/16 x minus 4 squared plus 3. This is my vertex form. To get it to standard form, I do order of operations. X minus 4 squared is going to be x squared minus 8x plus 16. I still have the negative 1/16 in front and the plus 3 behind. I distribute this negative 1/16 to all parts. So I have negative 1/16 x squared, negative 8 divided by negative 16. Those negatives cancel, I get plus, and 8 divided by 16 is the same thing as 1/2. So 1/2 x. 16 divided by negative 16 is going to be minus 1. And I still have the plus 3 that's out there by the side. I combine those addition-like terms, and I end with y equals negative 1/16 x squared plus 1/2 x plus 2. That is standard form. For 18, I have a focus point at negative 4, negative 1, and a vertex point at negative 4, negative 5. So I'm going to label those as my vertex and my focus. The vertex gives me h and k. So my focus form, I have x plus 4 squared equals, to figure out the 4 p-value, p is going from the vertex to the focus. So I move up 4, so my p-value is 4, making 4p 16. And then I have y plus 5. That 5 coming from my k value of negative 5. To get this to vertex form, it's y equals 1/16 x plus 4 squared minus 5. X plus 4 squared, so now I need to go from vertex form to standard form. X plus 4 squared is x squared plus 8x plus 16. I still have the 1/16 in front and the minus 5 behind. Now I distribute that 1/16 to all parts. So I have y equals 1/16 x squared plus 8 divided by 16 is 1/2 x plus 16 divided by 16 is 1, and then I have minus 5. So here, my final answer in standard form is y equals 1/16 x squared plus 1/2 x minus 4.